Hello, this is Anthony with Copley Controls. Today we'll be making interpolated position mode moves using a TwinCAT structured text program. So right now I'm connected over serial to a BEL drive, and we can see that we're in CAN open over EtherCAT mode, and we're just monitoring the drive's health over serial. So I will start up TwinCAT, and we'll create a new XAE project. Scan for devices. Okay, TwinCAT found the drive. And we're not going to use an NC configuration because we'll be doing a structured text program. And we'll click on the drive and we'll make some changes to the settings. First thing we'll do is go to the Startup tab. These are SDOs that are used to map process data and enable some settings. So we want to change the mode of operation to a value of 7 because the mode of operation that we'll be testing is interpolated position mode. So I'll click the Edit button, change this to 7. And then I'll add another SDO to change the interpolated position mode, the sub mode of this. So it has several sub modes. We'll be testing out the linear interpolation with variable time segments. So the way this works is you send down a bunch of positions and then associated time values, and the drive will interpolate between those, and it'll store those inside of an internal buffer. So map this, and we'll set it to a value of -2. Okay. That was -2 in hex byte swapped. So I'll go ahead and go to the process data. Now we'll edit the PDO mapping. So I'll go in here, create some RPDOs. And the first thing we'll map is the interpolated position, followed by the interpolated time. So for every position, we have a time value. Also, let's get access to the buffer itself. So if we have to clear it or enable it, we can do that. Great. So that should be enough for RPDO data. These are commands to the drive. Now we'll go into the TPDO data, and we'll add a TPDO. And this one will just tell us how many points, how many free points we have in the buffer. So if the buffer is empty, this should be reading 64, because that's how many points the drive can store internally. And when it's full, it'll read 0. So that's the PDO mapping. Now we can go ahead and create the PLC project. So let's say okay. Alrighty, now we have all these folders. The first thing I'll do is define some structures. So these will be structures used to manipulate bits for different objects. So the one of the most important objects is the control word. So I'll create a struct for that, and we'll do another one for the it's twin the status word. Okay, let me define these bits. Okay. Now we will create a global variable list. So this is a list of variables that we will link between our PLC project and the PDO channels. So we have the status word here, the actual position, the number of free locations on the buffer, the control word, the interpolated position command value, and then its associated time value, and then access to the buffer itself. So if you want to enable it or clear it, and then the control word, kind of a local copy of the control word. Alrighty. We save this, and then we'll now create some more functions. These are handy functions that we'll be using. So I'll create one that clears the faults in the drive. And I'll create another one that will enable the drive. So to clear the faults, all you have to do is toggle bit 7 of the control word. And then to enable the drive, all you have to do is set the control word to a value of 15. Okay, now we'll go to the main program. And here are our variables. This is a short list of variables. We'll have one local variable called iterations, and that just counts up how many times main is called. And then the change in position, that's just what it sounds like. For each interpolated position that we command, we'll be incrementing it or decrementing it by this value. And so the first thing we do is we'll increment the number of iterations, so how many times main is being called. If it gets over 100,000, we'll just reset it to prevent any kind of integer overflow or wrapping. And here, if we're not enabled in the status word, reading this bit, then we'll check if there's a fault, and if there is a fault, we'll clear it. If we're still not enabled, we will set the target position, the interpolated position command equal to where we currently are, so we don't get a following error, and then we'll enable the drive. That should get us enabled and holding position. After that, we will, after 300 iterations, we'll go ahead and enable the buffer. So now we're actually sending commands inside of the drive's interpolated position mode buffer. And this is a simple function or a if statement that keeps us within plus or minus 100,000 counts. And then if the buffer is full, then we'll start the move. So we won't start the move until the number of free spaces inside of the buffer is 0. Then we'll set these 2 bits. So this sets the control word equal to the value of 3F. And then, once we get over a certain number of iterations, we'll actually start to increment the interpolated position mode. So this is where we'll start to see the motor moving. So a very simple program just to test the functionality. So now I'll do a build. and we'll get a message saying that we have to link to a task variable. So all that means is that these global variables here that we've defined, we have to link them to the process data. So we go in here and we do that. Okay, I believe that's everything. Now I'll go ahead and save, clean it, and we will rebuild. Okay, then we'll activate the configuration. We will download it and start it. Okay, we can see the actual position here is changing. If I go in here, let's go ahead and open up the scope in CME. This is the nice advantage of being connected to CME over serial. So here we can see that we are indeed staying within about 120,000 counts, because there are some latched positions inside of the buffer, but we're able to start this. We're able to move in the interpolated position mode. So we're linearly interpolating between positions. We have 10 milliseconds between these positions. And yeah, profile velocity looks great. And we have a nice sawtooth waveform here for the position. So yeah, this is how you'd move, begin a move in the interpolated position mode. If you wanted to end this mode successfully, you just set the interpolated time, this value right here, just set it to 0, and that'll stop the move. Because you tell the drive, hey, I'm done sending you data. The next point is 0 milliseconds away. There is no next point, so just go ahead and end the move. So yeah, I hope this was helpful, and like and subscribe for more motion control content.